aquí en Chile y donde estén oyéndolo. Es un placer enorme para mí estar aquí, la segunda vez que vengo al Congreso del Futuro. Y me encanta la idea de forzarnos a pensar a cada uno de nosotros desde diferentes perspectivas de dónde venimos, cómo queremos que sea la humanidad del futuro, cómo tomamos ventajas de todos los hallazgos científicos y tecnológicos que son realmente formidables, pero que si no tenemos cuidado pueden también ser utilizados por efectos malignos. All of a sudden I realized, perdónenme, me di cuenta que estaba hablando en español y iba a hablar en inglés y no sabía si iba a hablar en español o iba a hablar en inglés. So I was forced myself, and I had to make a decision, and I sort of say, okay, I have to make a decision. Am I going to speak in Spanish or English? And now I'm finding myself speaking in English. And my main question in my talk today is how can we use the knowledge that we've derived from the investigation and the science of drugs and how drugs can produce addiction in an individual to enlighten us, to give us a perspective about how to look at how to use digital technologies and how to look into the future and how to actually get an understanding of that very basic process. I was finding myself spontaneously deciding, do I speak in English? Do I speak in Spanish? That element about what are the brain systems that actually determine what are my choices. And my choices are actually not something fixed. My choices are very much dependent on the context in which I find myself, but also on my own needs. And what's fascinating about drugs is that drugs stimulate that specific system that is responsible for activating and for motivating and energizing our behavior. It is responsible for actually us deciding what is it that I'm going to do right now and what is it that I'm going to do tomorrow. If I hadn't had food, for example, for 24 hours, it would be an extremely valuable commodity for me to be able to engage and find food, because if I don't find food, I'm going to starve. And that becomes my priority. That's the most salient stimuli that I have. But once I'm satiated and I know that I have to come here and give a talk to all of you, then food becomes irrelevant. It no longer has a value. And that shifting of the relative value of stimuli in our environment are specifically driven by a chemical in our brain, the dopamine neurotransmitter. And the dopamine is a chemical signal that actually makes communication between cells possible. But what's really very unique about the dopamine system is that actually it is the one that signals reward. And think about it. It's a sort of actually in terms of the creation and the simplicity and the elegance of biology. Biology has to have self-organization. It has to come up with solutions that actually allow you for an individual or a cell or a complex organism like all us as individuals or as society to engage in behaviors that are going to ensure our survival and the survival of our species. That is dopamine. That is at the essence of actually this dopamine reward system. Very simple. You want a behavior to be repeated? Make it rewarding. So if I eat food and it's pleasurable, I am going to repeat that behavior. If I touch something and I burn myself, I'm going to avoid that behavior. And that leads me to rapidly learn and to modify my behaviors accordingly. And it so happens, by pure randomness of chemistry and nature, that we have chemicals, artificial chemicals or natural chemicals like cocaine or nicotine, that can actually, when ingested, can stimulate that reward system. Now, that reward system is certainly not there for us to take drugs. Absolutely not. It is there to motivate behaviors and actions necessary for survival. But there are chemicals that come around and can activate that system. And what you see over there is that, yes, as I said, food is very important for all of us to survive. And not surprising, dopamine goes up when you actually eat food or when you see food and you're hungry. Look at drugs. Drugs are much more powerful in activating that dopaminergic system. And thereupon, why they can be so malignant. Thereupon, why, while any one of us can take a drug and perceive it as, oh, it's pleasurable, rewarding, and sort of, it's an interesting experience. But with repeated use, or in individuals that are vulnerable because of their genetics, or because they grew up on environments that were very traumatizing to them with adverse childhood experiences, they are more vulnerable to those rewarding effects of drugs, and they repeat them. And as they repeat them, the brain starts to change. And it changes in ways that the person, there is a point that it transitions from that ability to take a drug and feel a pleasure and say that's enough, to the transition where the person no longer even feels pleasure from that drug, but it's unable to control it. The ability to control, it's an automatic behavior. And because of these effects of drugs, as you recall by the media, using a term and a metaphor that is very precise, and is that drug enslaves the person. It enslaves the person because it removes the ability for self-regulation and decision-making. And thereupon, that understanding how the dopamine system, because is manipulated by drugs, ultimately determine how we actually are modifying our behaviors and choices, becomes so very, very relevant, of course, not just for addiction, but ultimately who we are and what are the motivations that we do to do things. The dopamine system, strategically, is in the center of the brain. That's where the dopamine cells are. And it sends projections to the pleasure center, the accumbens. And then there are the accumbens, the pleasure centers, sends basically two main projections. One to our frontal cortex. The frontal cortex is an extremely complex area of the brain where we do abstraction, decision-making, working memory. But it is the area of a brain that does exactly what I was telling you before. It assigns value to reinforcers. And so it is the prefrontal cortex that says, should I do this, or is it better that I don't do that because that's going to get me into trouble? But it's also this prefrontal cortex that determines, once I make a decision, I'm not going to do that. I'm able to carry it through. It's not automatic. Then the prefrontal cortex has to work properly for me to be able to engage it. So, not surprising, the prefrontal cortex actually determines the value of a reinforcer, and that then determines me how I'm going to act upon it. And it is bidirectional. That dopamine cells project to these reward prefrontal areas, and the prefrontal area regulates and modulates the dopamine cells themselves. But it also sends projections into the emotional areas of the brain, the limbic areas, classically amygdala and hippocampus. And this is also why, when we have a rewarding stimuli, it can help us in our sense of well-being, and why adverse stimuli actually can lead to negative emotional states. And that is modulated by dopamine. So welcome to dopamine, welcome to drugs, and welcome to drug addiction. So what is it that we can do? Well, dopamine, yes, it starts with reward. It's like something that seduces you. I mean, it's sort of pleasurable reward. But what happens when you get exposed to an unexpected reward, a novel one, your brain changes. And your brain changes in ways that you are not conscious. It basically triggers learning memory process that are actually different from the ones that you convey when you try to say, who did I meet yesterday? So you are consciously aware, you're trying to remember. Those are memory process. But the memory process that are triggered by dopamine are linked with the experience of that reward that you felt. And it automatically engages systems. You immediately learn it. You get conditioned, which is what Pavlov discovered so many, many years ago, except he didn't look into the brain. Had he looked into the brain, he would have seen that when the animals learned to associate the little bell with the food, and they started to salivate with the bell only, dopamine was going up. Dopamine is not just reward, it is learning memory condition, and it energizes our behaviors. So you can see how beautiful this design system is, and it's a system that's actually very easy to hack artificially. So we can now use imaging technologies to actually look at this in the human brain, because it is very valuable to look at laboratory animals, but we have a level of complexity as human beings that actually leads us to try to understand at a very fundamental process how that pertains to us. And using imaging, for example, this is an old study that we did where we actually have a marker, a radioactive marker that can bind to the receptors, the dopamine receptors, when these are empty. But when we give a drug and the drug raises dopamine, which is what it does, then the radioactive compound can no longer bind. And by comparing the difference between the radioactive compound binding when there's no drug to your left versus when there is drug with dopamine competing into your left, then you can see the relative changes in dopamine that drug did. And we can ask the subjects, we measure their subjective experience. And using this technology, and we and many others, have shown effectively that in humans, just like in animals, drugs increase dopamine. And the magnitude of that increase, in turn, is associated with the rewarding effect of the drug. And this, of course, is corroborating and documenting that this process is very effectively targeted by drugs. And it had led, based actually on initially studies in laboratory animals, and also later on clinical studies like this one, to the hypothesis that why is it that not everybody that gets exposed to drugs becomes addicted? And why is it that some people are more attracted to drugs than others? And yes, there are multiple factors that determine one or the other. But the hypothesis that was there was that people who actually seek out drugs, people that are addicted, in them, you see a larger change in dopamine. They are more sensitive to the effects of the drug, and therefore to the dopaminergic enhancing effects of the drug, and therefore that drug is more rewarding, more reinforcing, more motivating. And so that was a very theoretically acceptable hypothesis. And so, but with these technologies, one can go beyond saying, I hypothesize, to directly evaluate this. So studies, we've done multiple studies, and I'm illustrating with one of them just to show you. Basically, we were totally and absolutely wrong. We had hypothesized people that are addicted to drugs will show a much larger change when you give them the drug than those people that are non-addicted. And in the histogram over there to your right, you can actually see the response of normals, and you can see the response of people that are addicted to cocaine, which was 80 to 70% lower than that on healthy controls. It was markedly attenuated. So no, they don't have an enhanced response. They have a very, very attenuated dopaminergic reactivity to a drug, a chemical that we know by its pure nature is one of the most effective ways of activating dopaminergic systems. And you saw it with comparisons with food. So think about it, what does this mean in terms of the reactivity of that brain of a person whose response to a very powerful stimuli is barely visible? So yes, in this case, even though the response is so very, very weak, in these individuals that were addicted to cocaine, it was sufficient to engage them in wanting that drug. It triggered that hunger for the drug, that want, which goes much more than like. It becomes a need. And I want to say this because that's an element that people that don't work with addiction don't really comprehend. And the whole notion, oh, you can choose. Why don't you choose stopping taking the drug? That's a typical response that we get. It is, if I can choose not to do things that I like, I don't always have to do things that I like, but it's the issue of a transformation that is equivalent of a state of deprivation. And I started by saying if I haven't eaten 24 hours, then the value of the food would take over my mental state and make it the priority. So that's what happened. Actually, if you speak with people, if you care to listen to people that are addicted, you can see their responses. And there was one that was really very graphical in my brain because I couldn't conceive of something that was a greater need than that. And this person said, you know, it's like when you cannot breathe. That hunger of air, that despair of not getting what you need, that sense that you will not survive. That's what addiction has done. And it is driven by these very weak responses. And it is also driven by what Pavlov described. The drug itself basically creates a very blunted response. but the learning that has been imprinted by the drug, by dopamine, engaging and linking the response that that person got to their surrounding environment when they experience it, to the persons that they were interacting with, to the mental state that they had, actually is associated, it's conditioned, such that when they encounter the same place, all of a sudden dopamine goes up, and that leads them, energizes them to want to do the behavior. That's the only way that when you apply it to biology, we would survive. Because if I see something that predicts food, and I don't put the energy on that behavior to secure it, I will not succeed. Not in the past. Right now, yes, I only open the refrigerator and there's the food, but not in the past. So evolutionary, these are systems that are linking the pleasure with the learning and memory, with the energy to sustain the behaviors. And that's why addiction is so very, very malignant. And when you take that and says, well, what does that have to do as we look into the future? And that's where my last diagram, I said, and I've been repeating it, we do not have these dopaminergic systems to take drugs or becoming addicted. But they do provide systems that can be easily hijacked for malignant purposes. At the same time, it can be hijacked to actually incentivize us, to inspire us to do things. I like that question. I mean, certainly one of the most powerful reinforcers that we have is each other. Don't give it for granted at all. One of the most reinforcing things that we can feel is to feel appreciated and cared and loved by others. One of the most aversive stimuli that we can get is to be discriminated, to be rejected, to be ignored. And that's why social media can be so very powerful. Because with these very simple algorithms and clicks, like, dislike, you can actually engage the system that evolutionary has gone for millions of years to ensure that we do certain things and do not others. So as I was thinking at that very specific question about what is it that we like, the humanity, to look into the future? I know very clearly what I don't want it to be. I don't want these digital technologies, social media, or other screen patterns to make us into slaves. I want that technology, that humanity to emerge. I want us into the future to use these extraordinary tools that we are developing to maximize the value that each other has by themselves and in interactions with the other, and to incentivize and inspire the responsibility that each one of us has to make that happen. Thanks very much for your attention.